Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I discussed methods of preparation of amines. Today I will start physical properties of amines. But before discussing physical properties of amines, some problem is there based on preparation that I want to discuss, because that type of question is asked in examination. Then first I will tell the question, then I will explain it. Question I am telling you, that is the structure and IUPAC name you have to write. Okay, question is like that. Write structures and IUPAC names of first the amide which gives propanamine by Hofmann-Bromamide reaction. Again you listen question. You have to write a structure and IUPAC names of first the amide which gives propanamine by Hofmann-Bromamide reaction. Second question is the amine produced by Hofmann degradation of benzamide. I will explain one by one. First you can say explanation means you have to write the structure and IUPAC name of the amide which gives propanamine by Hofmann-Bromamide reaction. Then here propanamine contains 3 carbons. Hence the amide molecule must contain 4 carbon atoms. This is the very, very important. Propanamine contains 3 carbons. Hence the amide molecule must contain 4 carbon atoms. Structure and IUPAC name of the starting amide with 4 carbon atoms is CH3, CH2, CH2, C double bond O, NH2. CONH2 is the amide. Then if you will add 3 carbon chain CH3, CH2, CH2, again CONH2, then this will be butanamide. Hofmann-Bromamide degradation reaction, its characteristics, you know that this here in this degradation reaction, what will happen? Migration of an alkyl group or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. And here important thing is that that you should know here in explanation, the amine so formed contains 1 carbon less than the present in the amide. 1 carbon less. That's why amide what it require, that should be 4. Correct? That amide should have 4 carbon. Then that compound is butanamide. Then you will get propanamine. Okay. Then its IUPAC name will be butanamide. And structure is very simple. CH3, CH2, CH2, CO bond, C double bond O, NH2. Now next explanation of the question. That question was the amine produced by Hofmann degradation of benzamide. Benzamide. Again listen, the amine produced by the Hofmann degradation of benzamide. Means benzamide is a starting material and you want what type of amine is produced, that you want to know from benzamide. Then here again same things will be applied. This principle only. The amine so formed contains one carbon less than that present in amide. Here also same things. But here question is the amine produced by the Hofmann degradation of the benzamide. That question you have to answer. Then here benzamide is an aromatic amide containing 7 carbon atoms. Benzamide has 7 carbon atoms. Then if you will get amine, then that amine must be 1 carbon less. Correct? Benzamide is an aromatic amide containing 7 carbon atoms. Hence the amine formed from benzamide is aromatic primary amine containing 6 carbon atoms, 1 less. Means actually here benzamide means with benzene ring CH2NH2 is attached, not directly NH2. That is a benzamine. If with benzene NH2 is directly attached, that is called benzamine. But benzamide means CH2NH2. Okay. This thing benzamide, CONH2, not CH2, CONH2, that is the amide group. Then CONH2, when it is attached to the benzene, that is called benzamide. It's total 7 carbon. But in benzamine, that with benzene NH2 is attached. Correct? Then what will be this structure and IUPAC name easily you can understand, because this benzamide C6H5 CONH2, that will give C6H5 NH2 will be attached. Correct? Then here you will get a structure will be C6H5 NH2. Okay. Then here that compound will be aniline or benzamine. Here you will get 6 carbon. Benzene is phenyl group has 6 carbon, but this you got from the 7 carbon. C6H5 CONH2, total 7 was there, but now you got aniline, that is a benzamine. Okay. Then this compounds contain 6 carbon. Okay. That is a benzene amine. Now I will come to the physical properties of amines. Actually, what I discussed the question problems, that type of question is asked particularly in medical and engineering. Other examination also it is asked. Okay, whenever you find any type of this type of problem, you must try to solve it. Now physical properties. The lower aliphatic amines are gases. The lower aliphatic amines are gases with fishy odor. Fishy odor. This smell will be of fishy odor. Primary amines with 3 or more carbon atoms are liquid. This is also important point. Primary amines with 3 or more carbon atoms are liquid, and still higher ones are solid. Aniline and other aryl amines are usually colorless. Aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. Lower aliphatic amines are soluble in water because they can form hydrogen bonds with water molecules. However, solubility decreases with increase in molar mass of amines due to increase in size of the hydrophobic alkyl part. Listen, this point is important. Lower aliphatic amines are soluble in water. Why it is soluble? Because they can form hydrogen bonds with water molecules. However, solubility decreases with increase in molar mass of amines. Why? Due to increase in size of the hydrophobic alkyl part. Higher amines are essentially insoluble in water. Higher amines are essentially insoluble in water. Considering the electronegativity of nitrogen, of amine, and oxygen of alcohol, that is for amine, it is 3.0. Electronegativity of nitrogen of amines and oxygen of alcohol is 3.0. It is for amine, and 3.5 in case of oxygen in alcohol. Okay, you remember this value. If you consider electronegativity of nitrogen, of amine, and oxygen of alcohol as 3.0 and 3.5 respectively, what you will find? You can predict the pattern of solubility of amines and alcohols in water. Here you must know that for solubility hydrogen bonding is must. Correct? Out of butane 1 all and butane 1 amine. Now consider this, out of butane 1 all and butane 1 amine, both are butane. Which will be more soluble in water and why? This is the question. It is asked. This question is asked in examination. Now just to listen. Amines are soluble in organic solvent. Amines are soluble in organic solvents like alcohol, ether, and benzene. Okay, and also you should remember that alcohols are more polar than amines and form stronger intermolecular hydrogen bonds than amines. Okay. Primary and secondary amines are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. Okay, this point is important. Listen again. Primary and secondary amines are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. This intermolecular association is more in primary amines than in secondary amines. Okay. Why? As there are two hydrogen atoms available for hydrogen bond formation. Okay. Here intermolecular association is more in primary amines than in secondary amines because there are two hydrogen atoms available for hydrogen bond formation in it. Tertiary amines do not have intermolecular association due to absence of hydrogen atom available for hydrogen bond formation. Therefore, the order of boiling points of isomeric amines that I will tell you order how, because this hydrogen bonding is different, then boiling point will be also different. Then what are the order of primary, secondary, tertiary, that I am telling you. Primary will be greater than secondary will be greater than tertiary. Okay, means primary amine boiling point of primary amine is greater than secondary and secondary is greater than tertiary. And here already I told you that in RNH2 primary amine is RNH2, then 2 hydrogen is attached with N. Then now other RNH2 you consider, two molecules of primary amine you consider, then N of first and H of second both will attract to each other. That is a hydrogen, they will attach to each other by hydrogen bond. Again second and third molecule also can they can also make a bond. Okay, like that way third and fourth also, because now aniline 2H is there, then both side 2 hydrogen is there, then it can make with both side 2H is there, then down also, up also. Okay, and if other amines are present, then it can make bond with 2 hydrogen bond with 2 hydrogen with other amines, correct? And that's why its a boiling point will be more. When it is making only one bond, then boiling point will be less. If it is making with 2, boiling point will be this thing, not primary. I told you primary because it has 2 hydrogen, hence its boiling point will be more, because 2 hydrogen are there, they can make more hydrogen bond with other amines. And in secondary only 1 hydrogen is there. Here also they will make bond but less hydrogen bond. That's why its boiling point will be less, because it will require less heat to break the bond, correct? And tertiary no hydrogen bonding, correct? Then primary will have more boiling point than secondary, and secondary will have more than tertiary. In tertiary no hydrogen bonding, and its boiling point will be less. Okay, no heat is required, and because no bond is there, hydrogen bond is there, then no extra heat is required. But primary will require more than secondary. Hence, a boiling point of primary amine is greater than secondary. Secondary is greater than tertiary. Okay. Now, I am going to discuss chemical reaction. Chemical reaction. Difference in electronegativity between nitrogen and hydrogen atoms and the presence of unshared pair of electrons over the nitrogen atoms make amines reactive. Why amines are reactive? Then two reasons are there. First, difference in electronegativity between nitrogen and hydrogen atoms. And second, the presence of unshared pair of electron over the nitrogen atom. These makes amines reactive. The number of hydrogen atoms attached to nitrogen atoms are decided or you can tell the number of hydrogen atoms attached to nitrogen atoms also decide the course of reaction of amines. That is why primary means NH2, secondary NH, and tertiary only N. In NH2 one valence is opened, in secondary 2 valence is opened, in tertiary 3 valence is opened. Okay, and these amines differ in many reactions. Moreover, amines behave as nucleophiles due to the presence of unshared electron pair. They should remember why amines are nucleophile. Then its answer is that due to the presence of unshared electron pair. Now some reaction I am going to discuss. Basic character of amines. Basic character, you know that any atom or molecules, in molecules particularly any atom, when they are in a position to donate the electron, if they can donate the electron, particularly in amine, nitrogen has lone pair of electron, it can donate the electron to the other atom. Then this tendency to lose the electron or donation of electron to the others, that is called basicity, basic character. Any atom in a molecule, any atom in a molecule, if it can donate the electron or it has a, you can say, lone pair of electron, then that will have basic character. Okay, then reaction I am telling you, amines being basic in nature react with acid to form salt. Very simple things. Acid reacts with base and it will form acid plus base. Always it forms salt. Then here amine is basic, RNH2, correct? Then N has lone pair of electron. Then if acid is there, as for example H plus, acid means H plus, then N can donate electron to H plus. H plus means H has no electron. Then when nitrogen will donate electron to hydrogen, it will make the bond and it will form NH3, but here H will be directly, H will not come, HX, suppose it is HX, then H will be H plus, X will be X minus. This is the acid, like HCl, HBr, HI, all are acid. Then suppose HX is there, X is halide ion, X will be negative, H will be positive. Then here nitrogen will donate electron to H, then it will form RNH3X. HX was there, that will come near the amine. Then N and H, it will form bond. Then now it is called salt, because now H became plus. After the donation of electron, H became plus. Then N made bond with H, and with H, X is attached. Then RNH3X. Then H is positive and X is negative. That's why it is called salt. Salt. Okay. RNH3X. This is the salt. Okay. Like same way, aniline. Aniline, if it will react with HCl, then same way will happen. Only benzene ring is there, that is the different case. But reaction will be with N. Lone pair of electron that will provide. And same things it will form. It will form anilinium chloride. Means C6H5, NH3, Cl. N is positive, Cl is negative. Okay, this is called anilinium chloride. And next things you should know that amines salts on treatment with base. Amine salts like RNH2X, you have seen RNH2X. N is positive, X is negative. Then amine salts on treatment with a base like NOH regenerate the parent amine. Very easily you can understand these things. If amine salt reacts with base, you will get original one. Amine salts on treatment with a base like NOH regenerate the parent amine. Okay, means now OH, suppose NOH is there, then what will happen? NaOH. Then Na is plus, and here salt was there, RNH2X plus NOH, then Na plus. That Na plus, that will go to the minus, means with X, it will form NaX. Suppose X is Cl, then it will form NaCl. And OH is minus, then H will join here, it will form water. Then what you will get? You will get original RNH2. Amine you will get. Hence RNH2X plus base, like just like OH minus, you will get RNH2 plus H2O plus X minus. Correct? If you will take complete HCl, NOH, complete NOH, then you will get NaX plus H2O plus RNH2. This is the important things. Amine salts are soluble in water but insoluble in organic solvent like ether. This reaction is the basis for separation of amines from the non-basic organic compounds insoluble in water, because one is soluble in water, other is soluble in ether. Correct? That is the organic solvent. Hence separation can be done. One is soluble in organic solvent like ether, other is soluble in water. Okay, hence this is the you can say basis for separation of amines from the non-basic organic compounds insoluble in water. The reaction of amines with mineral acid like HCl, H2SO4, HNO3, these are called mineral acid. Means inorganic acid, also called inorganic acid. The reaction of amines with mineral acids to form ammonium salts shows that these are basic in nature. Okay, other proof. The reaction of amines with mineral acid, that is acid only, and it will form salt, it will form ammonium salt. This shows that these are basic in nature. Amines have an unshared pair of electrons on nitrogen atom, due to which they behave as a Lewis base. Basic character of amines can be better understood in terms of their Kb and pKb value. Means how a strong base it is, then you can understand by either by Kb value or by pKb value. Both are inversely related, correct? If pK value is more, if Kb value is more, then pKb value will be less. You remember, inversely proportional. Okay. Then here you can get the expression of K. Chemical equilibrium expression, you know, that can be applied here. Means RNS2, when it will react with water, it will form RNS3 plus OH minus, correct? Because lone pair of electron will be given to H plus, then RNH3, it will form RNS3 and will have plus charge, and automatically, because from the H2O, H gone, then OH will remain, OH minus. Then this is the equilibrium reaction. This reaction is in equilibrium. Hence here you can apply this chemical equilibrium principle. Okay. Then here you will get K is equal to concentration of products, you know, concentration of products divided by concentration of reactants. Then here molar concentration of RNS2, means you have to write in big bracket, and into molar concentration of OH ion divided by molar concentration of RNS2 into molar concentration of H2O, that is equal to K, means equilibrium constant. And then you know that here H2O is in excess, then just you write this H2O with K, means K into H2O. Then what is remaining now? Upside RNS2, that is N is positive ion, into OH ion, molar concentration of RNS2, correct, ion, and molar concentration of OH ion divided by down only RNS2 is remaining, molar concentration of RNS2 is remaining. You have H2O written with K, correct? That is the equilibrium constant. Then this, when actually H2O is in excess, H2O is feebly ionized, means it will be ionized very, very less. Then suppose you have taken 100 moles, then 1 mole may 1 or 2 mole only will dissociate. Majority of H2O will be not dissociated. That's why it is considered as a constant, almost constant. That's why it is brought with K value, and K and H2O together, it will be, you can write a new constant, that is called Kb, correct? That is this dissociation constant of base, Kb, correct? Because here here Kb means base dissociated, base dissociated, correct? Then that dissociation is very less. That's why here with the K you are writing B, Kb. Kb means that is the dissociation constant of base. Then Kb is equal to what? Kb is equal to now R molar concentration of RNS3. Upside I am talking about. RNS2 become RNS3. RNS3 positive charge means cation into molar concentration of OH ion divided by RNS2. Upside is RNS3. Okay, don't forget, but that is the positively charged. Then this is actually expression for Kb, and this Kb you can write in the form of PKb. Then PKb only, that P means here minus log, you remember. P means minus log base 10. Then if Kb you want to tell in the form of PKb, then you should write PKb is equal to minus log Kb. In the place of P, you are writing minus log base 10. Okay. Then now PKb is equal to minus log Kb. Larger the value of Kb or smaller the value of PKb, I told you, inversely proportional. Larger the value of Kb or smaller the value of PKb, stronger is the base. Just to remember, if Kb value is more, then base is stronger. Or another way, if a PKb value is less, then base is strong. Just like acid, same way. If Kb value is more, then obviously PKb value will be less. Both are related inversely. Okay. Then if Kb value is more, then base is strong. Or in another way, if PKb value is less, then it is also telling strong. PKb should be less for a stronger base. Correct? This you don't forget, don't confuse. Both are telling for a stronger only. If PKb value is more, then it is strong. If PKb value is less, correct, then this is also a strong. Any one you remember, then you will not get confused. Kb value remember. If Kb value is more, then base will be strong. Okay, then PKb value in a reverse way, automatically you will understand. Okay, less the PKb value, more the strong. Just it will apply for both, for acid also, for base. There you can tell pKa or Ka or pKa. A means here acid. Okay, pKb value of ammonia is 4.75. You remember. Some common value you should remember, because question is asked, and only by knowing sometimes they will not give the value. Then if you are knowing some common, not all, common, then you can answer the question very easily. Larger the value of Kb, okay, or smaller the value of PKb, stronger is the base. Okay, PKb value of ammonia is 4.75. Aliphatic amines are, again you listen, all are important point I am telling you. Aliphatic amines are stronger bases than ammonia due to plus I effect, inductive effect of alkyl group, leading to high electron density on the nitrogen atom. This you remember. pKa value I told you for ammonia is 4.75. Now other important point, aliphatic amines. Aliphatic amines are stronger bases than ammonia. Why? This is due to plus I effect, means plus inductive effect of alkyl groups, leading to high electron density on the nitrogen atom, because ethyl group will attract the electron, then it will make this alkyl group plus I effect. I am telling you, this is the plus I effect, alkyl group leading to the high electrodensity on nitrogen. That here any alkyl group, methyl and ethyl, that will provide more electron, then they will give they will have more electron, hence that will be prove more basic. Okay, then aliphatic amines are stronger bases, because aliphats this alkyl group will provide more nitrogen, this more electron to the nitrogen. Okay, electron density on nitrogen atom will increase. Okay, this alkyl group leading to the high electron density on the nitrogen atom. Correct? And after supplying the electron, alkyl group will become positive. Alkyl will become positive. That's why it is called plus I effect. Their pK values lies in the range of 3 to 4.22. Okay, that is this aliphatic amines. What will be the value? Then its value will be lie in the range of 3 to 4.22, in between 3 to 4.22. On the other hand, aromatic amines are aromatic, because that will benzene group will not supply the electron, because it is stable, resonance stabilized, that benzene ring, it will not supply electron. On the other hand, aromatic rings are weaker bases than ammonia due to electron withdrawing nature of aryl group. Here that it will work in a negative way. It will attract the electron. Benzene ring or you can say aromatic amines, that in aromatic group, that will attract the electron. Then nitrogen will be not in a position to supply the electron, hence basicity will be less. Then aromatic amines are weaker bases than ammonia due to electron withdrawing nature of the aryl group. You remember, aryl group will attract the electron and alkyl group will give the electron. Okay, it will supply the electron. This you remember. Okay, this actually question is asked this on the basic nature, and here you will find some discrepancies also. Discrepancies you will find here. While if you will get many values, then you find some discrepancies. Okay, means some differences you will find, and what you can tell, some exception also. Now I will tell about the one more thing here. You understand that Kb values of amines on the basis of plus I effect or minus I effect of substituent present in amine. This differences or some discrepancies. For that, what is the reason? That is the plus I effect or minus I effect of the substituent present in amines. Only that way you can understand, or exception. Besides inductive effect, there are other effects like solvation effect, steric hindrance. Why this discrepancies? Then its reason is that first reason is plus I effect or minus I effect. Second reason is solvation effect. Third reason is steric hindrance. Okay. These effect, these solvation effect, hindrance effect, plus I effect or minus I effect affect the basic strength of amines. Okay. Now I am talking about just you should know about the structure basicity relationship of amines. Structure and basicity relationship. How a structure is related to basicity. How both are related of amines. That is called a structure basicity relationship of amines. This basicity of amines is related to their structure. Basic character of an amine depends upon the Iitjee of formation of cation by accepting a proton from the acid. You know that how much positivity nitrogen is getting. That depends, that tells about the basicity, or how much Iitjee it is accepting the proton, means H plus. That is also telling about the basicity. Basicity of amines is related to their structure. Basic character of an amine depends upon the Iitjee of formation of the cation by accepting a proton from the acid. The more stable the cation is relative to the amine, more basic is the amine. Okay, again you listen. The more stable the cation is relative to the amine, more basic is the amine. Means positive charge if creating more, and then it means more basic. The more stable the cation, if cation is more stable, okay, after losing the electron, the more stable the cation is relative to the amine, more basic is the amine. Now alkyl amine versus ammonia. Question is asked. Alkyl, this alkane amines versus ammonia. Then which one is stronger? Try to understand by a structure. Now consider the reaction of alkane amine, RNH2. RNH2 with N2 hydrogen is attached and N has one lone pair of electron. Now suppose H plus is coming, then what will happen? N will give electron to the H plus and it will form RNH. RNH2 was there, now it became RNH3. N is positive charge. N is positive charge. Then this is actually, here R is attached. That is called alkane amine. R is attached to the NH2. But if it in the place of R, H is there, means then it become ammonia. Same way it will form ammonium ion in NH4, because now in the place of R, H is there, then it will form ammonium ion NH4 plus. Okay. Then now just these two structure unite, just you understand. In one case R is attached, in other case H is attached. NH2 is as it is, and it has joined the H. Then it is forming a new bond with hydrogen. Okay. Then now you consider this alkyne and ammonia. Then due to the electron releasing nature of alkyl group, it pushes electron towards the nitrogen and thus make the unshared electron pair more available for sharing with proton of the acid. Moreover, the substituted ammonium ion I am talking about. Moreover, the substituted ammonium ion formed from the amines gets stabilized due to the dispersal of positive charge by the plus I effect of the alkyl group. Okay. Hence the alkyl amines are stronger bases than ammonia. In ammonia it is not like that, but in alkyl is electron donating group. Okay. Then it makes the this alkyl I am talking, the R pushes electron towards nitrogen and thus make the unshared electron pair more available for sharing with the proton of the acid. Correct? And this is the one point. Second point, substituted ammonium ion formed, because RNH3 plus it formed, that is the also ammonium ion, but alkali R is attached, that is also you can tell substituted ammonium ion. This is actually formed when the amines get due to that amines gets stabilized due to dispersal of positive charge by the plus I effect of the alkyl group. When alkyl group is attached, due to that it is plus charge is dispersed and it becomes stable. But in case of ammonia, this does not happen. Okay. Hence the alkyl amines are stronger bases than ammonia. Thus the basic nature of aliphatic amines should increase with the increase in number of alkyl group. This trend is followed in the gaseous phase. The order of basicity of amines in the gaseous phase follows the expected order, means tertiary amine is greater than secondary amine is greater than primary amine, and primary amine is greater than ammonia. Ammonia is least. The trend is not regular in the aqueous state, only in the gaseous state. You remember, this trend is valid only in gaseous state, not in aqueous state. Okay, as is evident by their K's values. Okay, in the aqueous phase, the substituted ammonium cation is get stabilized not only by electron releasing effect of the alkyl group, but also by solvation with water molecules. This is the important point. In the aqueous phase, the substituted ammonium cation is get stabilized. I am not that point by gaseous state which is stronger. I told you this is another point, that the substituted ammonium cations gets stabilized not only by electron releasing effect of the alkyl group but also by solvation with water molecules. Okay. The greater the size of the ion, lesser will be the solvation. You remember, question is asked, the greater the size of the ion, lesser will be the solvation and less stabilized in the ion. Okay. The order of stability of ions in aqueous solution, I am telling you that now that RNH3 plus was there, primary you consider, primary amine, RNH3 plus one H has joined, then obviously it is the cation RNH3 1 plus on the N. Then if solvation means attachment with water molecules, then here here N will attract, N is positive, or you can understand RNH3, then 3H is there and on N positive charge is there. Then H is electropositive, then that H will attract the water molecules OH2. It will be attracted by O of H2O and it will make bond. Correct? Then here not only 2, 3 you can say, 3H is there, then all 3 H will attract the water molecule by making hydrogen bond H and O. Water will be attracted by H. 3H are there, all 3 will attract the water molecules. That is called actually solvation. Then this is greater than secondary. Why? In secondary 2 alkyl group will be attached. Then only 2 hydrogen will be available. 2 hydrogen will be available. This is also cation. On N plus is there in all 3 cases. Then here 2H is there, then now it will attract only 2 water molecules. 2H is there, then H and O bond they will make. H2O, that O and H, one bond, other bond with other H. Then here 2H2O is going to be attracted. That's why it is secondary only 2. Then primary is greater than secondary. Okay. This is I am talking about order of stability of ions, means cations. And in tertiary 3R is there, and no hydrogen is there. Only 1 hydrogen is there, which N has donated electron, 1 hydrogen came. Only 1 is there. Then that will join with only with 1 water molecules, H and O. Hence it is a weakest. In stability, that tertiary is the weakest. Then stability of ions, then primary amine is greater than secondary, secondary is greater than tertiary. Okay. This is actually decreasing order of extent of H bonding in water and order of stability of ions by solvation. Now by this structure you can understand, because every time H bonding is becoming less in all 3 cases. In tertiary it became least, and in primary it is highest. That is called decreasing order of extent of H bonding. And other cases, that is the order of also this stability is decreasing, least is in tertiary case. That is called order of decreasing order of stability of ions by solvation. Okay. Now Now just again further I want to tell you, greater is the stability of a substituted ammonium cation, stronger should be the corresponding amine as a base. Thus the order of basicity of aliphatic amines should be that order I am taking again. This is the important question for examination. The order of basicity of aliphatic amines should be, primary should be greater than secondary, secondary should be greater than tertiary, which is possible to the inductive effect based order. Secondly, when the alkyl group is small, like a CH3 group, there is no steric hindrance to H bonding. Correct? This is a very important point. That second important point, when the alkyl group is small, like CH3 group, there is no steric hindrance to H bonding. Correct? In case the alkyl group is bigger than CH3 group, there will be steric hindrance to H bonding, because size will be big. Then H2O can't make a bond with H. It will disturb. If size is big, then steric hindrance will be there. OH will not come. It will be difficult for the H2O to make a bond with H. Solvation. That it will create problem. Then there will be a steric hindrance to H bonding. Therefore, the change of nature of the alkyl group, that is from methyl group to ethyl, results in change of the order of basic strength. This is a very important point. Thus, there is a subtle interplay of the inductive effect, solvation effect and steric hindrance of the alkyl group. Solvation effect and steric hindrance of the alkyl group, which decide the basic strength of the alkyl amine in the aqueous state. Correct? This I told you, that subtle interplay of the inductive effect means first is the this important play I am talking about, that there is a subtle interplay of the inductive effect, solvation effect and steric hindrance of the alkyl group. These three factors, inductive effect, solvation effect and steric hindrance of the alkyl group, which decide the basic strength of alkyl amine in the aqueous state. All things I told in aqueous state. The again important point I am telling you, the basic order of basic strength in case of methyl substituted amine and ethyl substituted amine in aqueous solution is, I am telling you, that is as follow. Means if NH3 3H is there, then 2H is, suppose it is substituted with ethyl group, means C2H5 whole 2 NH. 2 ethyl group is present there. Then here I am talking about basicity, order of basic strength. Then this is, because 2 ethyl group is attached, this is a more basic than if 1 C2H5 is attached. 3 ethyl group is attached, C2H5 whole 3 N. Then when 2 ethyl is attached, then it is stronger. When 3 is attached, means C2H5 whole 3 N. And this C2H5 whole 3 N is stronger when only one ethyl group is attached with NH2, means C2H5 NH2. Correct? When it was 2 ethyl group attached, then only one H was remaining with N. Then C2H5 whole 2 NH. This is stronger when a 3 ethyl group is attached with N. All H is substituted with ethyl. Why? Because due to the this esteric effect, C2H5 only 2 are there in the first case, only 2, less hindrance, but now 3 are there, C2H5 whole 3 N. That's why this C2H5 whole 2 NH is more basic than C2H5 whole 3 N. And this is more when only one ethyl group is attached with nitrogen. Okay, this C2H5 whole 3 N is more than C2H5 NH2, and this is more than NH2, correct? And this CH3 whole 2 methyl group here, it is attached. This is the another just point to understand. If CH3 whole 2 NH, this CH3 whole 2 NH is stronger than CH3 NH2. CH3, when 2 CH3 is attached with NH, this is stronger than 1 CH3 attached to NH2. Only one is there, and this is stronger than when 3 CH3 is attached with N. Remember, because 2 methyl group is there, then it is methyl group, a small group, hence it will be more basic when in comparison to that when one methyl group is attached to NH2, and this is greater than when 3 is attached, 3 methyl groups attached with N, 3 are there. Again number increased, then stirring effect little increased, that's why it became less. And CH3 N2 is more basic than CH3 whole 3 N, and this is more basic than NH3. Then these 2 points I discussed, question is asked. Okay, in almost all IIT, particularly advanced level, this question is asked. Okay, now I am stopping only here. Next class, actually many properties are there, then I will discuss in next class. Okay, thank you.